Hello everyone. Good morning or welcome to this course. For my students in this subject, which is Fundamental Physics 1, we are going to do our lecturing in online system. So you can download these matters and all of the details in the aula. So we are not going to do in Zoom. So let me introduce myself. I'm Heri Trilaksana. You can call me Pak Heri or just Heri. And in this subject, I will be in partner with Bu Fitriah. And Bu Fitriah will do in the second half. So I will do in the first half before the midterms exam. First of all, today is the first class, so we are going to tell you about something in brief, why we need to do this subject, Fundamental Physics 1. Actually, we have some of the study program need Fundamental Physics 1 and 2, but some others might not be need to take the Fundamental Physics 2, so they just have Fundamental Physics 1. So from my memory, maybe the information systems or mathematics, they don't need the let's have a look with the curriculum. So some of them will need the Fundamental Physics 1 and 2, but some others just Fundamental Physics 1. The details of the Fundamental Physics 1, the code is FID 101, and that's 2 credits of subjects, and this is the lectures, me and Bu Nurul. So I will do before midterm exams, and Bu Nurul will do the second. This is a bit ridiculous actually, because we are going to do online, but we still constrained. We are still constrained by the times, day, like the rooms and the classrooms. So I think this is just because we need to do some administrative stuff, administrative requirement, that we still need to put all the times we need to do the exam, we need to do the lectures, as well as the room where you are going to do. So in case this situation, the pandemic situations, is done, so we need to go back to the offline learning process or study process. So we need to come back to the uni, and this is the slot for doing the lecturing. But while we are doing the subjects or lecturing online, this time is not limited, so we can do any times. That's why I don't need to do Zoom, because while when I'm doing on Zoom, so you can't do anything else. But if I just put my recording here, so you can do any times. You can do at night, you can do in the morning, you can do whenever you have a free time. So you can do other subjects while they are still performed in let's say Zoom or Google Meet or whatever, any platform. But I don't want to interrupt all of the courses, but I will do sending my recording, and then you can listen up over and over again. Okay, so I think this a bit more helpful for students. And also I just try to make the file of my recording and my PowerPoints as low as I could. Okay, so it won't be won't be ruining your internet quotas. Okay, so yeah, that's what I supposed to do. And this is the identity of the courses. So this is fundamental physics 1. The code is FID 101, and this is a weight 2 credits. So 2 credits can be defined as 150 minutes per credit. So if 2 credits, so you need to spend 300 minutes per week to learn about this subject. So 300 minutes could be the lecturing, in this case the online lecturing, which is 50 minutes times 2 because it's 2 credits, so 100 minutes per lecturing. And then your independent learning process at home, because you need to read the textbook, you need to browse on the internet sources, and so on and so on, as well as you need to do your assignment. So there would be assignment, or we call as PR, homework, for this subject. So if you count over all of these activities, it should be 300 minutes per week. Okay, so that's kind of the quantity, how long and how much you need to learn. This is semester 1, 2020-2021. And I want to tell you that I'm going to this courses in English, but I have no idea about Punurul, if Punurul want to do in English as well. So yeah, that's what we're supposed to do, because in Faculty of Science and Engineering, we already have accredited by ASIIN, if you might be familiar with the international accreditation from Germany. So we already been accredited by the SIIN or ISIN. So the mandatory of this requirement is at least for the first year, from my memory, 20% of the courses need to be performed in English, and it was 2 years ago. And at the second year, which is last year, should be in at least 40% of the subject need to be performed in English. And at the moment, at least, because it's the third year, let's say 2.5, roughly 50 to 60% of all the subjects need to be performed in English. We can do both. The talk or speech can be done or performed in English, as well as the PowerPoint and all of the materials. Let's say it's written in English and the talk will be in English, or we can do just, for example, the written in English and the lecturing are still in Bahasa Indonesia, or the other way around. The matters like what we had here, my PowerPoint text here is still in Bahasa Indonesia, but the talk, what I'm saying, I'm doing in English. So in both, or any way I'll do, that's still acceptable for the international accreditations. So because you are a new student and you might not be quite familiar with the what's going on in the Faculty of Science and Engineering, Science and Technology, this is what actually happening. Okay, so this lecture is for the faculty or the School of Engineering as well. So for the School of Engineering, because they're still just the first year establishment, so they need to catch up with other study programs, which is in science and technology, because these two school and faculty are very close in terms of what they learn, what they need to do in the curriculum and study program and learning process. So we are going to be very, very close. Such as this fundamental physics 1 and 2, we are going to be at the same lecturing. Okay, so I will do the same both for either for the faculty of science and technology, faculty of science and technology, as well as for the School of Engineering that like the classes I need to handle. Okay. And as I said before, that these courses will be performed or handled by myself. This is my names on the left bottom corner, and Bu Nurul Fitria will do after midterms. And this is 2 credits, so it started from 7 until 8:40 in the morning every Wednesday. And the room is going to be in the Faculty of Science and Technology, the Faculty of Science and Technology room 301B, which is in the level 3. So this is in the South Wing buildings. If you pop up in the Faculty of Science and Technology, so you come to the South Wing and go through the stairs until level 3, and this is on the east side. So 301A, and then the next one is 301B, next one is 301C, and so on. So that's what we usually do in offline lecturing, but because we are doing it online, you can do just following what I'm sending on the Aula system. If you are not familiar with Aula system yet, then you need to download or go through the university website, type googling with the keyword Aula semester whatever, Kasal or Kenap, and the academic year. So for example, now we are in semester 1, 2020-2021. So you need to Google that Aula semester Kasal 2020. Okay, go through that, and then you will find what you need to, or you can do from your student account, and then you go through the Aula, click the Aula, then all of the courses that you are doing on the semester, the consecutive semester. So you start with semester 1, semester 2, and because you're still a new student, you might just have semester 1, and then you hit the semester 1, then all the subject you're taking in semester 1 will be come up. Okay, so you pick up with the fundamental physics 1, and then you will have all of the materials that I uploaded or Bu Nurul uploaded there. Okay. Okay. If I look through this slide, the picture is a bit scary. This horrible picture. Why do we need to put this scary picture here? Just because we want to tell you or let you know about the facts around the students. All the high school students, might be most of them, they're scared of physics. Yeah, they're scared of physics just because physics is very, very complicated. It's hardly to be understood. So this is quite general picture that physics is hard. But on the other hand, physics is interesting. So we need to pick up with the correct ones. While the physics is very, very hard, it's just because you hate physics, you're scared of physics. But if you want to move to the other way or the other point of view, that physics is very powerful, physics is very, very descriptive, physics is very, very physics does very, very make sense. So you can physics are very, very logical. So you will end up with the feeling that physics is very, very challenging and it's interesting. So yes, physics is hard, but as long as you have the spirit that while you are doing all the hard things in physics, such as you will have the heavy mathematical stuff on it, or you will have to read the story, the paragraph very hard because it's very conceptual. So just try to find some sources, some pictures, some video, some sources that can help you to understand what the hard things in physics. I think in this era, we have already had the multimedia, the digital sources, that the internet is very, very easy to be accessed. So you are going to search on the internet on all of the matters around the world very easily. So I think you can select which one. Sorry. You can select which one is more helpful for you, which ones is in the specific considerations. This is very, very suitable with your level of understandings, because if your understanding is not that high, then you pick up the matters very high, so it's not going to be very interesting. You're gonna feel that the physics matters are very, very difficult. So just pick up the source. First of all, you pick up the sources on the textbooks or the Googles or other internet sources with some very easy and suitable with your level of understanding. Start from that point, you will be getting improved. It's very, very slow. You can't jump up into the very high level because you need to crawl up very, very slow, because it's the conceptual things in physics is hard. Yeah. So this is a bit challenging, but it's quite promising if you have a very high passion and good motivation spirit. Physics is going to be very helpful to build up your logical, to make everything that looks very make sense. So then we could change the phenomena that physics is momo is in the Japanese language, which means horrible or it's scary. Physics is momo, then coming up to the physics is mimic. Do you know what mimic? Yeah, mimic means they can be explaining very clear what actually happening under nature. So by doing physics or having the good or very well understanding in physics, you're gonna have the very good mimics to interpret or to evaluate or analyze what actually happening in the nature, because what you got from physics is actually the interactions between the matters and its energy, and whatever happening in the nature, that's related to both things, the matters and its energy. So you can describe anything in physics. This is just a short descriptions with what you are going to have in physics. So physics is actually the derivative of the philosophy. So the thinker just like to think everything they investigate in the nature. The philosopher, we call that philosopher. So after the philosopher, they need to be a bit more detailed with some explanation and descriptions. And after philosopher, we will have the physics, or let's say science, yeah. And then science is just a bit more normative. Everything is about science. Yes, I know chemistry is science, biology is science, computer is science. But out of all of the science, we need to be more detailed. What's actually happening on the science? And to discover this value, we need to learn about something in details. In details, how we describe clear, how we describe in very, very in depth or details. So physics can do this. So after philosopher, we have science, we have physics, and after physics, we will have a kind of branch, all of the science, chemistry, biology, computer science, engineering, and so on and so on. So that's why physics called as the fathers of science. So fathers of science. What about mathematics then? Mathematics is part of science. How to interpret all of the story behind the science in short or in specific way, which is clearer and more what we call it, more hierarchical. So mathematics is just the other way to explain what physics does with a specific language, which is mathematical. So mathematics is the language for science. Without mathematics, we can't do any descriptions or explanation what is happening in science. So mathematics is the science language. Okay. So by physics, using the physics, we can do the understanding about the phenomena, about the natural law, kind of the Newton law 1, 2, and 3, and then some interaction between the object, the matters or the particles to the surrounding, the environments. Could be heat, could be electric, could be the magnetic field, what kind of interaction, a lot of interaction. So they change from one form of energy into the other form of energy. So this is very, very, very general views about phenomena, physics laws, and its interactions. And what's actually physics contribution to others? So as I said before, that physics is the put everything at the same frames, which is science, and then from the science you will have very good understandings to apply it into the daily activities or daily life. So for example, you have the problems in your life about, let's say, transportations, about, let's say, to transport one good to others from one place to another. So you need to have the way how to deliver these things. And in this case, you understand the science, what you need to do, and then you will construct or build or develop the technology. The technology could be the vehicles, the technology could be the system, the queues, the order, how to do the delivering from one to another. So basically, physics could be as the fundamentals of science itself, technology, or even some economic and social things, because in combination between physics and math and mathematics, you will have something a bit more statistical. Okay, so in this term, statistical can be very, very useful for economic and social, because all the variable in economic and social is very, very linked to each other, very, very complex, and it's hard to resolve all of the variables. So we need one disciplines about statistics in combination between your mathematics and natural things. Okay, so it's a bit of the multidisciplinary, but physics is actually there. Okay, how you learned about the fluctuative or how the rapid change of, for example, the stock or the demand in economics, the fluctuating things is very, very statistical, and you can apply all of the dynamical function in physics to predict or to project what actually happening, what's going to happen in the next 2 weeks or a month or next year, to project what based on what's actually happening in the past. Okay, so physics can do both, can do all of these things. This is the benefits for the benefits of these subjects. This is a kind of the basic science that can facilitate you to learn about the technology, the medical things, the chemist or pharmacist, as well as the biology, sport, and all of the applied physics in the frames of physics as the fundamental science. And it could also be very, very beneficial for the students who are very, very scared of physics. Then this is the chance for you to change your minds, rather than you decide to put your mind that physics is horrible or is scary. So you can switch your minds that physics is mimics other than just momo. Okay, and fundamental physics could also be a pillars of other physics disciplines. So this pretty much might be the students in physics study programs, when they need to learn a bit more details of the other pillars in physics, such as thermodynamics or electromagnetics, waves, or quantums, or modern physics, spectroscopy, or other applied physics. So they need to understand that fundamental physics 1 and 2 is very, very big pillars, strong and big pillars that you need to have. Otherwise, your building's gonna be very weak, and it's harmful for everybody who are not very good in fundamental physics 1 and 2. So hopefully students can have a good mark, represents that you have a good understanding for fundamental physics 1 and 2. Okay, so that's why it's very important to deliver the fundamental physics 1 and 2 to students very clear, and how the student need to be very active to build up the understanding for them, so that they are not going to be very, very suffering a lot of hardship while they are doing the studying at the university because of physics. So the student can also interpret and apply what their understandings about physics in the daily life activities. So someone who are doing something good and having very well understanding in physics, usually they can look at the phenomenology in the daily life very differently. They will be very, very clear to to look through the phenomena, and they have a very clear reasoning, and the more important thing is they will have any insight that they can do what they need to do, because life is about choices, right? You have very, very lot and abundant choices, but which choices you need to pick up, it depends on what's your understanding about the phenomena. So for example, this is the COVID-19 outbreaks. So based on the COVID-19, we changed significantly. We changed very dramatically. Our habits, our activities, all of the business were changed. So in this kind of phenomena, very, very update phenomena at the moment, the students can decide what should we do to be the winner in the future. So everybody are not allowed to come to the classroom. Everybody are not allowed to do offline classes. So everybody needs to do online. For the cognitive point of view, for the understanding about the concepts, it's not a big issue, because you can learn from other sources for the books, literature, for the PDF file on the internet, from what your lecturing process methods, you can download everything and you read it out very, very easily. But for something related to the skills of what you can do, like the psychomotoric, you need to do something with the laboratory activities. It's a bit hard, because you are not allowed to come to school, you are not allowed to come to uni, and then you need to do something actually. So this is kind of the challenging thing that all of the students has. So in these terms, by having the physical or understanding about physics, you can do, like, for example, to keep your progress in doing something in laboratory or whatever. So you can evaluate, what could I do? Okay, I don't have any instrument. I don't have any kind of what the laboratory has. But on the online system, you can look through some videos, look through some descriptions about all of the experiments. Such thing, for example, in physics, there's one experiment which is very, very hard to be understood, but it's very crucial. Let me pick up with the inertia moments or gyroscope. When you have the gyroscope, you need to do very good in you need to do your gyroscope in the frameworks. Okay, so you need to have the very, very clear understanding about the frameworks or laboratory frames. In this competence, you can find some illustrations on the internet, or you can still have some videos to help your imaginations that gyroscope is working as it is, how the gyroscope works. So back to the physical concept. You read through the literature, you derive all of the equations, you need to have a good understanding in calculus, in algebra, then you used all of those to break up all of the hard mathematical things, and then you end up with the very, very close to the conclusion why we need to have a good understanding for gyroscope in inertia moments sections. So you have still had like very, very hard struggles, because yeah, I know it's not easy. Even you come to the uni or to the schools, you come to uni, you come to the labs, you already had the experience that on the experiments you will see that's the gyroscope, and then what do we need to do next? Because for some reasons, if you're coming to the schools or to the uni, and then you're doing the experiments, such thing that you already have done very, very well, because I'm attending the class, I'm attending the laboratory works, and then everything goes very well. This is not true, okay? Because this is not about routine. You're coming to the uni, you understand about something, but you need to make sure that, do I understand about something? Did I get something very beneficial for my understandings? You need to make sure that what you're doing every day at the uni is very, very beneficial for your purpose, why you are doing or study in these study programs. Okay, so this kind of the why we need to understand what the beneficial things for ourselves. So this is the consecutive path of the beneficial why we need to understand the subjects very well, very clear. So first of all, you need to have a very well understanding about the fundamental aspects that physics is very, very crucial for your continuing studies in the future. And then secondly, you will have an idea that you will understand the aspect that the phenomena, the physical phenomena on your life and your environment will be understood very clear. And then finally you will get the very wise and not only wise, but you have a very complex and complicated considerations about your decisions on your life. So what you should do regarding to your understanding in physics and your constraints. So you will have a good directional what you are going to do on the next or let's say in the future. So that's the aims why we need to have this this concept. Okay. And then in this slide, this is just the detailing of all of the subsections. The chapter 1 will be talking about the units and measurement, and then factors. Then starting with the kinematics particles 1, 2, 3 dimensions. Then you move up to dynamical particles, Newton law 1, 2, and 3, and then works and energy. Okay, and then particle systems and the conservative law of momentum. This is one of the preliminary or the introduction to the dynamical rigid body. So it could be rotation, could be linear motions, as well as here the stability of the rigid body. So this kind of I think until this dynamical rigid body, this is before the midterm exam, and then starting from the fluids mechanics, and then vibrations, mechanical wave, and thermodynamic things is pretty much after midterm exam. So this is the second half. So this is what you will learn in Fundamental Physics 1. The aimings, why we need to understand about the Fundamental Physics 1 after you took this course. So you're supposed to have ability to calculate all of the physical phenomena, the simple physical phenomena on mechanics, thermodynamics, wave, and use all of these concepts in physics in the daily life activities or daily life phenomena. Okay, so you're supposed to have this ability, understanding this simple physics phenomena, especially in mechanics, thermodynamics, wave, and use them on your daily activity. And obviously you need to understand the concept, and you can do all of the problems in the exam, otherwise you are not pass the lectures or the subjects. Okay, so good luck for this struggling. And this is just the picture or the transitions from the aims or the goals of the subjects and the descriptions, what you need to have, what the ability you need to have after these courses. You need to understand and apply your understanding about simple physics phenomena to your daily activities or daily life. And these pictures, the methods organizations here are the most important things, because for some reasons why physics looks very scary, because you are overwhelmed with what all of the chapters, what all of the subjects in physics are located. So you need to know what is the order, the consecutive buildings of this concept. So first of all, you will have the first very fundamental in physics. You need to understand about the properties of physics. You need to understand of the units, the dimensions, and measurements. And then you will go to the vectors analysis, even it's just the algebra one without the calculus one. And then you will start with the force and stability. And the other hand, you will start with kinematics 1 dimensions, kinematics 2 and 3 dimensions, and then straight away you can go to the fluid on the left hand side here, and then start with the temperature, heat, or in Bahasa Indonesia we call it calor, so heat, and then thermodynamics law here at the very end, the left top corner. And for the other path here, you can start with vectors and kinematics 2 and 3 dimensions, start with the dynamics, and then works and energy, then dynamics of system particles, and then dynamics of rigid body, oscillation, waves, and wave mechanics. So this is how all of the chapters or the subjects in fundamental physics 1 will be related one to others. And this is the strategy of the lecturings. We'll be doing in lecturing or talk and speech. So I will do some descriptions. That's why I need to record what I'm telling about. And then we will have a discussions. And then we will have the visualization on demonstrations. If it's possible, it's a bit harder to get this one. But let's do our best, okay? So the most important thing here is about discussions, because in discussions, you can have a very actively contribution to our understandings. So when you build up your understandings, for some reason, it's a bit hard because you don't have any partner to discuss about what you're understanding. This is very important for students to express their understandings around. You can do to your friends, you can do to your teacher, you can do to all of the society, the communities, couples of people. Then they will ask you some question. They will clarify about what your understanding has. And then you will reply from the discussion. So discussion is important, okay? Discussion in any level of understanding, discussions are important. So you need to have more and more frequent in discussions, because on the other hand, you will have also the motivation, the spirits, because while you're doing the discussion, a lot of interaction will facilitate what you're gonna potentially do. So for example, my understanding in vector algebra is not very good. So whenever all the problems related to the vectors calculations, it's gonna be horrible, because I'm always confusing, and it's confused me a lot, because I don't know which one is the degrees. The degrees is 30 degrees from where? What is the reference? And then from this 30 degrees, in which direction I will put another factors. So it's confused a lot. So on this understanding, you need to discuss with some others, okay? and some others will tell their understanding to you, and for some reason it's going to be very, very beneficial, very, very effective. You can cut the time you need to spend if you read through the literature, because you can do the discussion very quick. And another things, from this point you will have a stronger motivation and spirits to look through back into the literature, just because you will have another discussions. While you have another discussion, maybe next week or the following days or next 2 weeks, you will show them to the audience, to your friends, to your teacher or lecturers, that I'm moving up to that level. So I need to improve from this level to the next one, which is higher than before. So this is kind of the motivation the student need to build up personally, because it's going to be very unique. The students might be very different in comparison to others. So individuals are unique. So you can build up your understanding, you can facilitate all of what you need to do, and it's very, very personal. Okay, it's very, very personal. So as a lecturer, I just try to facilitate all what you need. If you have any questions, if you have any discussion, you need to ask something, just feel free to write your questions and send it to me, whatever on the WhatsApp or on the Aula or whatever, in any platform. You can have the opportunity or chance to ask what you're confusing about. Okay, so this is the mapping of the strategy of the lecturing. There's a tutorial, which is lecturer will do some speech or talk, and then discussions. This will be facilitate on lines on the Aula or WhatsApp, if it's possible for you, because we have the WhatsApp group for this subject, and you can do your own or self-study opportunity to build up your understanding. And demonstration, we will have the demonstrating of the phenomena, visualization through the internet or some videos, e-learnings, whatever you can do on the internet. And this is the proportion of your scores, how we evaluate on the subject. Soft skill is 10%, the assignment is 15%, quizzes is 15%, and then mid-test and final test. So a soft skill usually is coming from your attendance. So as long as you do all of the sections, all of the lecturings, so you will get 10% out of all those. And then the assignment is going to be maybe once before the mid-test and once after the mid-test. The quizzes similarly is once before mid-test and once after mid-test. So this kind of assignment and quizzes are very, very helpful or beneficial for students once you are not very good in midterm exam or final term exams. So if you are not very good in both or one of those, so assignment here and quizzes will be very helpful. So don't miss any assignments or quizzes. Just do it very, very well and thorough, then you will get the good mark in assignment and quizzes. So it's going to be very helpful to accomplish all of the mid-test and final exams. Okay. So I think from this slide until the very end of this PowerPoint, This is going to be describing all of the activities on the lecturing. So for example, this is 9th September, which is today, and then we need to have the lecturing about the contract or the introductions, as well as the units, factors, and the measurements. Okay, and then if you look through the second one, it's gonna be 16th of September, and then it's about the kinematical particle. And then the third one is 23rd of September, and so on and so on. You can look through it. I don't want to waste time here. You can read very thoroughly on the PowerPoint. What I'm going to say is the next slide is about the reference. So this is the reference that we are going to use on the Fundamental Physics 1. The first one is Tipler 1991, which is in Bahasa Indonesia. You can read through it, but if you want to improve your English, so you can have another one, Alonso and Finn, Fundamental Physics. This is the in English version. I'm not quite sure that Alonso and Finn has Indonesian language. So I don't think that Alonso and Finn provided in Indonesian versions. So Halliday and Resnick 1994. It is already translated into Bahasa Indonesia, so you can have this one as well. And there's couples of the PDF files, but that's in English, so you can have it very easily on the internet, and it's very updated. It might be 2012 or 2014, something on that year, not as old as this one. This is just the third one, right? The third edition here. So this is the I think number 4 is very helpful. Halliday, Resnick, and Volcker. Yeah, this is a bit different to Halliday, Resnick in 1994, because this is in edition 7, the 7th edition here. I think it's around 2000 something, whatever, 2004, 2006. Jewett and Selby, there's a bit more calculus based, and then as well as the other Jewett and Selby in 2008, Physics for Scientists and Engineers with Modern Physics, Volume 1, 7 editions. And you can look through it and find all of the PDF files on the internet. This is another option how we do the assignment and the evaluations. As I said, the assignments usually when we are doing the offline lecturing, the assignment before UTS or midterm exam is going once or twice, and then another one after the midterm exams once or twice. So we will have 4 assignments. But in online lecturing at what we have at the moment, we will do the assignments for each lecturing. So for example, the first one, you need to do the the assignment. So the lecturer will give the assignment before we are doing the lecturing. So kind of tugas pendahuluan in bahasa Indonesia. Okay, so for example, next week we are going to talk about the measurements and units. Then I will give you 1, 2, 3 questions, and you need to do this before the lectures, and then you submit it on the Aula, and then we will do this assignment. So you will have the components of your assignment, which is very good because you already done all of the chapters. So this is gonna be performed before the lecturing. Okay, so after number 2 year, after the lectures, you're gonna have the assignment, and then you need to submit the assignment before the upcoming lectures next week or the following weeks. So the more assignment you'll have, the more chance you will get a good mark, because we will have your activities on the assignment as well as on the quiz. Okay, so this is about the assignments. And then please don't do copy and paste on your assignments, and do your exam individually. Otherwise you're gonna be grounded, so you are not getting passed for this subject. And this is the proportions. What's your final score will be developed. So this is the range of A, more than 75. B is 70 to 74. B is 65 to 69. BC is 60 to 64. C is 55 to 59. D is 40 to 54, and then E is less than 40. So the final score is going to be in 0.9 times NHS, which is the hard skills, plus 0.1 times NSS, which is soft skills marks, and then 0. And you can follow. T is the average for your assignment. Q is the average of your quizzes, and UTS is the midterm exams in the midterms, and then final exam wise. Okay, so this is the formula how to calculate your final score. And this is about this soft skills will be constructed. You need to be honest to do your exam, your assignment. You need to be fair. Your attendance, you need to be completed all of the lectures. And then you need to be disciplined to do your assignments and your exams. So this kind of the soft skill will be collected from. And this is what the evaluation of your disciplines. You will follow all of the rules. You will come on times in this case, because we are going to have the online lecturing. So this point number 2, which is disciplines, you can do attending on times. So I will record these marks from the presents you're doing. So for example, we need to do the lectures on Wednesday 7 to 8:40. So for example, like that. So I don't ask you to play my recording and learn what the matters on that times. But what you need to do, you just need to sign up or sign into Aula at that time during 7 to 8:40. Okay, this is just the evidence that you pretending that you are attending the lectures on time. Okay, don't do the presents out of that period of the times. Okay, you need to do your presents of before between 7 and 8:40. So make sure that you sign up, because on the Aula, your attendance, your signing will be recorded in order. So who present first, they will coming up first. Okay, then the later they will coming up by the times. Okay, consecutively in order. So I will do these things just for the signing up or signing in. While you have already signed in and then you sign out, that's fine. You already present on your Aula. And I will do this for your soft skills. And the attendance is very clear while you're doing, and I will do this kind of the rules when we are doing offline. So not all of these case will be working. Such thing that you will titip tanda tangan. Okay, you will sign your friends or whatever. It doesn't an issue. It's not going to be an issue during or in online class. So just drop out this number ones on the second chapter here. You're not going to copy and paste on the exams, but yeah, the technology is very easy. But I will do this on the Aula system, so it's gonna be facilitating how to avoid the students, how to keep the student from not doing copy and paste. And then cheating, yeah, it's not for the during or the online lecturing, not the doing in working in team, because this individual exam. Okay. And I think from for the rest, you can read it out from the PowerPoint, and you'll see what you need to do on the PowerPoint. Okay, so I think that's all for these introductions. The first chapter, the first lecturing here. Thank you for your for listening these first introductions, and see you on the next lectures.